Here's some questions exactly as they're written in the past papers. Because they're diagrams, it's just a little bit easier to record this way. So this is a question from 2018, and it involves looking at radians and geometry and working out areas of sectors and that kind of thing. So it says the diagram shows an arc BC, so that's this part of a circle here, that's what an arc is, with center at A and radius 5 centimeters. So that's a radius of 5 centimeters, but also that's a radius of 5 centimeters. The length of the arc BC is 4 centimeters, as it says there. The point D is such that the line BD is perpendicular to BA and DC is parallel to BA. So that's just telling you that these are right angles in here and here. For 1 mark, find the angle BAC in radians. So that's theta here. So the angle BAC is that angle in there. Now we can work that out because the length of the arc divided by the radius is equal to the angle in radians. That's actually a formula that's given to you. So I've got a picture here from the actual formula sheet, and it says here that the arc length of a circle is equal to the radius times by the angle. I'm looking for the angle, so that's equal to the arc length of the circle divided by the radius. Okay, so that's what I've done there. I've gone the arc length, which is often given the symbol S, divided by the radius, which is R. So the arc length was 4, the radius was 5, so 4 divided by 5 is 0.8, and that's automatically in radians for 1 mark. We're going to need that number. In part II, it says, find the area of the shaded region BDC. So in this diagram, we want to find out this shaded region, and one way to think about that is that it's the area of this total shape minus the area of this piece of pizza, which is a sector. So this total shape is actually a trapezium. When you have one pair of parallel sides, so DC and BA, we're told they're parallel. And when you have one pair of parallel sides, then the shape you have is a trapezium. So to find the shaded area, it's going to be the area of the trapezium minus the area of the sector. So I think that's what I've written down here. The area is equal to the area of the trapezium minus the area of the sector. But first of all, we need some extra information to work out the area of these things. So the green line here, CX, is going to be given by some trigonometry. If we think about the angle theta, that is the opposite, and that's the hypotenuse. So the relationship there is sine. So this distance here is going to equal 5 times the sine of the angle, but we know what the angle is. Okay, so CX is going to be 5 times, sorry, green doesn't show up very well, 5 times sine of the angle, which is 3.59 centimeters. So this length here is 3.59 centimeters, the green line. And the blue line, in terms of the angle, is going to be the adjacent. And so that involving 5, you're going to have the cosine. Okay, so AX will be 5 times the cosine of the angle there. So AX is 5 times the cosine of 0.8, which is 3.48 centimeters. So this blue line here is 3.48 centimeters, which also allows us to find out this distance here, which is BX. And that's going to be important because we need to find out the area of the trapezium, which involves the length of the 2 parallel sides. We know this side over here is 5, but we'd like to know what this side over here is. You also need to know the distance between them, so that's where we found out the green length. Okay, so what is this distance here, this little distance XB? Well, it's going to be 5, the total height, minus the blue, which was 3.48. So CD, which is that little distance here, or there, is going to equal 5 minus 3.48, which is 1.52 centimeters. So I think I have all the ingredients now. I've got the length of CD, one of the parallel sides. The other parallel side is 5 because it's a radius of the big circle. And I've got the distance between them, which is the green. And so that's enough to work out the area for the trapezium. And the formula is like this. 1/2 times the sum, so add them together, of the 2 parallel sides, so the 1.52 there and the 5 here, multiplied by the distance between them, which was the green number, and they'll give me the area of the trapezium. The area of the sector is given by a half times the radius squared times by the angle in radians. And you're actually given that on the formula sheet. Here it is. The area of sector of a circle is a half times the radius squared times by the angle where the angle is in radians. So we found out that the angle was 0.8 and the radius of this sector is 5. So we're going to have a half times 5 squared times by 0.8. And if you work all that out, you get an answer of 1.70 centimeters squared. So there was a few little steps along the way, and we had to use a formula that was given for us, and we got our final answer for 5 marks. Okay. Now, you're going to be given this formula sheet, but some of it only is applicable for higher up Cambridge stuff. So some of these formulas down here, which look a little bit scary, you don't really need to know them. Not until you would be doing like year 13 Cambridge. So for example, you will need to know this formula, which is that tan is sine over cos, and also the Pythagorean identity, which is cosine squared of the angle plus sine squared of the angle is equal to 1. But some of the other stuff you won't need to know, but you're given it anyway. Okay, here's another question. I think this one's from 2019. And it says the diagram shows a semicircle ACB with center at O and radius R. And it says the arc OC, so that's that part there, is part of a circle with center A. So if that's the radius and that's an arc and A is the center, well then that must be the radius as well. So I wrote a little red R on my diagram there. Part I of this question, it says express the angle CAO in radians in terms of pi. So CAO. So we're trying to find out this angle right here. And we know that that's R and that's R. And we need to work it out in terms of pi. Well, probably the easiest way to work this question out is if this distance here is 2R and that distance there is R, and you should probably know that angles in a semicircle is a right angle, so the angle there is a right angle. And so I've got a right angle triangle. And in fact, if I had another copy of that right angle triangle and I flipped it over, I'd have what's shown in green. And then I'd have this distance being 2R, that would be R, and that would be R, so that total distance there would be 2R. And if this is 2R, then that's 2R, just because of symmetry. So I have a triangle, and every single side is equal to 2R, and if you have a triangle and all 3 sides are the same, you have an equilateral triangle. And if you have an equilateral triangle, the angle here is going to be equal to 60 degrees, or 180 divided by 3. Well, in terms of radians, the angles in a triangle add up to pi radians. So all the angles in a triangle add up to pi radians, and if all 3 of them are the same, then I just need to have my final answer being pi divided by 3. And pi over 3 is the same thing as 60 degrees. Okay, part II, it says find the area of the shaded region in terms of r, pi, and the square root of 3, simplifying your answer. And this is with 4 marks. So I need to find out the area of the shaded region, and the way I'm going to do it is I'm going to work out the area of this triangle, and then take away the area of this little sector, this little piece of pizza. So to work out the area of this triangle, remember that's a right angle, I can have R being my base, and CB would be my height, and then I could just go half times base times height. So I need to know what CB is. I need to know this distance here. Well, this distance here is R, and that distance there is 2R. If you forget about R just for a second, then that distance is 1, and that distance is 2, and that's a right angle, so we can use Pythagoras. So the hypotenuse would be 2, and one of the short sides is 1, so this other short side would be 2 squared minus 1 squared, which is 4 minus 1, which is 3, and then we need to square root it, so the answer there would be square root of 3, and then actually everything was in terms of R, so the actual answer here is the square root of 3R. Okay, so I've got that CB is equal to the square root of 3 times by R. That square root only applies to the number 3, and then you times it by the letter R. Okay, so this distance here coming from Pythagoras is the square root of 3 times by R. And now I can go ahead and work out the area of the shaded region. It's the area of the triangle minus the area of the sector, so the piece of pizza. So the area of this triangle here, I've got my base here of R and my height of square root of 3 times R. So half times base times height. And then the area of the sector again is half times the radius squared times by pi over 3, the angle which we found earlier. So the area of the sector here is given by its radius, which is r, and the angle in radians, which is pi over 3. So I've got this. Now I'm tidying it up a little bit, and I think all I did here was go that a half times by, or divided by 3 is a sixth, and I've got a half over here. I'd like to write that as in terms of 6 as well. So 1/2 is the same thing as 3/6, and that way I've got everything over 6. So my final expression, I've got everything over 6. I've also got r times r, which gives me r squared, and another r squared there. So everything's involving r squared. And then what have I got left over? I've got 3 lots of square root of 3 minus pi. So 3 lots of square root of 3 minus pi, all wrapped up in brackets. Everything involves r squared, and everything involves over 6. Here's a question from the 2020 paper. It says in the diagram, arc AB is part of a circle with center O. So that's a radius, and that's a radius, and that's why they're both 8 centimeters. And arc BC is part of a circle with center A and radius 12. So that's a radius which is 12 centimeters, and I guess in total that distance there would be 12. So that's telling me that that distance there is just 4, isn't it? Okay, and it says that AOC is a straight line. Yes, that must be 4. Anyway, for 2 marks, find the angle BAO in radians. So BAO, we're looking for this red angle here. We actually, if you take away the rest of the picture, you have a triangle, and you know all 3 sides, and we're trying to find out an angle. So what you need to use is the cosine formula, or the cosine rule. So the cosine rule in this case would be the inverse cosine of one of these lengths squared, so 12, plus the other length touching the angle squared, so 8 squared, minus the length that doesn't touch the angle, 8 squared, all over 2 lots of this length times that length. So 12 squared plus 8 squared minus 8 squared, all over 2 lots of 12 times 8. Find out what that fraction is, then inverse cosine it, and you get your angle there using the cosine rule, which is 0.723 radians, rounded to 3 cent figures. Okay. Part B says find the area of the shaded region. So finding the area of the shaded region here, we can think of it as the area of this sector minus the area of this triangle. Okay, so let's go ahead and do that. So the area of the sector minus the area of the triangle. The area of the sector is given by a half times the radius squared times by the angle. Well, we know what that is. The radius is 12, and the angle we found to be 0.723, so half times the radius squared times by the angle. And then the area of this triangle can be found using the triangle formula, which is a half times this length times that length times the sine of the angle between them. So I think I used that down there. Yep, half times 12 times 8 times sine of the angle between them. And if you work that out and you calculate it in radians, make sure you calculate this in radians mode for any question involving radians, you get 20.3 centimeters squared. And that's good enough for 4 marks. It's actually a last part to this question, part C. It says to find the perimeter of the shaded region. This one's only worth 3 marks. So the perimeter of the shaded region is made up of that part, which is 8. I think right at the beginning we worked out that that part there is 4. And I need to know what this arc length is here. So we need to know the angle, and we need to know the radius, and the angle times the radius will give you the arc length. And that was given to us way back over here, where it says that the arc length of a circle is given by the radius times by the angle. So, where am I? There. So the perimeter was, part of it was 8, the little part was 4, which we worked out, and then the radius times by the angle will give us the length of the arc. And if you add all that together, you get 20.7 centimeters for 3 marks.